Hello and welcome back. Today I really wanted to show off how I create floating damage numbers. These are a really cool little thing to add to any RPG game that allows the player to really understand how much damage they are doing after any calculations have been made. I threw together a really simple weapon system and little ammo system that we're going to flesh out together and actually add damage and a fun little animation to the numbers and things like that. Now I will show off what I actually created here. The weapon, as you can see here is a bow. I'm going to press play, and you can see it's just a bow that rotates around the player, and every time I left click it spawns projectiles. Now these projectiles don't do anything, they just fly off. That's it. Now how I actually made that, however, is if I scroll down here, you'll see under my resources folder I have the projectiles folder and a weapons folder, which can both contain data for each individual weapon. This is my preferred way of making projectiles and different weapons, is just resourcing them. So the resource here for the wooden bow is just a bow. It's of type bow, wooden bow, has the image, and then has the data for the ammo that it uses, which in this case is the wooden arrow, which just has its basic speed, the projectile, and the name. Now if I go up to the actual components section here and check the weapon component, you'll see all it is a node 2D with a sprite and a script attached to it. All this does is house the current weapon. It builds it, puts it together based on the weapon component data that it receives. It builds it out, and then every time we left click, in this case press the attack button, it will attack with the weapon, which for us is just firing a little projectile. Spawns in the new projectile, gives it an actual position as a child to the entity container, and then just fires it off in a given direction, which is usually towards the mouse. So with that done, let's actually go and look into what we actually need to do to give this damage. Very, very simple thing that you learn in game development very quickly is damage needs to be, as a piece of data, housed on something and then transferred to another thing to allow the other thing to read that data and go, oh, I need to apply this number to whatever health value I want to apply it to, or do something with it, right? Now, the easiest way of doing that, of course, is through hitbox and hurtbox components. So we are going to first start by making a hitbox component. So let's go and do that. This is going to be of type other node, and it will be an area 2D. Really simple. We're going to call this the hitbox component. I'm going to hit Control S and save. I'm going to go and save this under my entity components folder. Now I'm going to use Control A and I'm going to add a collision shape to the component itself, and then I'm going to hit Control S and save and add one script to the hitbox component. Now I like to give my hitboxes and hurtboxes class names, so let's go do that. Did I spell the right component? Yeah, I did. So what is a hitbox? A hitbox is an active box or a damage box. It's a box that houses a damage number. So if a character has a hurt box, or a receiving box, and they walk into a hit box or an active box, it will basically apply the damage that is housed on the hitbox or another part that goes through the hitbox. So that means we're going to need a damage value, right? So let's go var. Let's call it the current underscore damage underscore value of type int and set it equal to 1. Now we're going to need a function to deal that damage. Now this is going to be a really simple function. We're going to write func deal underscore damage, and it's going to return an integer value. Now what it's going to return is just the current damage value. Now the reason why I'm doing this is because this is a really good way of just getting the value for the current damage and then being able to use that in another place without actually grabbing the variable itself. Next thing I'm going to want to do is I'm going to want to create a setter function. So let's go func set underscore damage. It's going to need to be taking a new underscore damage underscore value of type integer, and it needs to return nothing, so void. And all we're going to do here is set the current damage equal to the new damage value. So now we have a way of getting our damage and setting our damage. The final thing is me just planning ahead a little bit. It's going to be a destroy function. So I'm going to write func destroy. Gotta put a little underscore before destroy here, just to say, hey, this only does one specific thing. In this case, it is a get parent q3 function. So that's what we're going to do, get underscore parent dot q3. Now the reason why I'm doing this is because it allows us to very easily q3 the projectile after it's hit something if it doesn't have any like piercing value or anything like that. So we can just very simply destroy it. Actually, let's remove that underscore. I don't like underscore. So that's it. That's our hitbox component done. Now what I'm going to do is I'm going to go down to collision inside the inspector, and I'm going to set this to layer 2 on both layer and mask. Now this doesn't actually need to do anything other than house the data and be an area 2D. So what we're going to do now is we're going to find that projectile that I created, in this case the projectile data, not the projectile data, the player projectiles, the base projectile here, and this is the base projectile. All it does is move in a certain direction by a certain speed. If I scroll down to where I am building the projectile, all I need to do here is add a hitbox to it. So let's open up the scene. Let's use Control-Shift-A and add a hitbox. Make sure I have saved this. I have hitbox component. Now I'm going to access that with a unique name, drag that in. That's the I'm ready for it. Now under build projectile, I can very simply just go hitbox component dot set damage. Now, a very, very interesting thing that I decided to do was not actually give the projectile any damage. So what I'm going to do is I'm going to go down to the projectile data script, the actual resource script itself, and as you can see here, it's just a projectile name, a texture, and a base speed. I'm going to write at export var projectile underscore base underscore damage. It'll be an integer value, and I'll set that equal to 10. Actually, we'll set that equal to 1 as the very base variant for every single projectile resource. So let's go to the wooden arrow here, and let's check. It now has populated with a projectile base damage. I'm going to set that to 10 here, so we now know our wooden arrow does 10 damage. Now I'm going to go back to the base projectile script, and inside of it, I'm just going to pass through the current projectile data dot projectile base damage. And that's the entire damage setup for the hitbox done. So now the hitbox is containing the actual damage it needs to do. And the best part about that is it doesn't actually know where that damage is coming from. It's just a value that's passed through. It doesn't need to know that it's a wooden arrow or anything like that. It's just, this is the value, pass that through. So the next thing I want to do is go and build a hurtbox component. So let's go do that. Actually, first, before I forget this, right click on the component, editable children, collision shape. I'm going to give this a quick collision shape. We'll go little rectangle, drag that down and in, make it a little bit smaller. There we go. That's better. Hit Control S and save. And now, hurtbox component. So hurtbox component is going to be the same thing. It's going to be an area 2D. We're going to rename this to the hurtbox component. I'm going to hit Control A and I'm going to add a collision shape. Now I'm going to very quickly just add a very simple little circle collision shape to this. Hit Control S and I'm going to save this inside the components folder again. Now I'm going to add a script to the hurtbox component and we'll give it a class name just like before. The hurtbox component needs two things. It needs a signal for receiving damage, so damage underscore taken. And it's going to need a function for its actual signal for a body or another area entering it. So let's click on hurtbox component, hit node, go down into the on area entered signal here, click that, hit connect, and now we just need to do a quick check. We just need to check if the area is of the type hitbox component. If the area is that, we want to use damage taken and we want to use dot emit and then area dot deal damage. That's going to return the damage value inside of the hitbox component and emit this out as a signal, which is going to be quite useful. And then I'm just going to call the area dot destroy function that I created. So it queues through the entire projectile itself. Now I'm going to hit Control S and save. And now we have a hitbox and hurtbox component, but we have nothing to attach the hurtbox to. So let's very quickly create a new scene. I'm going to do just another node. It's going to be just a sprite. I'm going to rename this to target dummy. I'm going to hit Control S and save. I'm going to save this under, we'll just create a new folder here, and we will call this just the dummy folder for now. I'm going to hit save, and I'm going to use Control Shift A, and I'm going to add a hurtbox component to this. Now, as I said before, I changed the collision shape, or the collision detection mode here on layer and mask to 2, so that's what we're going to want to do again for the hurtbox component. So I'm going to hit Control S and save. And I'm going to add a new script to the target dummy. Target dummy doesn't need a class name, but it does need to have access to the hurtbox component signal for damage taken. So we can just click or double click on that and connect it to the target dummy. Now that we are receiving that damage through, we can print the string variant of the damage we are receiving. So I'm going to hit Control S and save. I'm going to hit play after I put this in the scene. So let's go into the world scene real quick. Let's go under the entity container, hit Control Shift A. I'm going to add some target dummies. Just like so. Got to find them. There we go. Got to put one there. I'm going to duplicate that and put one there. Now this is a bit awkward because, you know, there's no sprite attached to these, so let's go and fix that real quick. Let's go to the target dummy. We'll go up to assets, art, tiles, and we're going to scroll down through and see if there is a target dummy somewhere in here. I know there is one. This is the Kenny Tiny Dungeon and Kenny Tiny Town asset packs. Let's go scroll down through Tiny Town, see if there's one in there. Oh, there it is. Tile 095. Now if I hit Control S and save and I hit play, we run over and now we can see there are two little target dummies. Now we're just printing out the damage every time the arrow connects with the target. There you go. In the bottom there we're seeing the amount of damage that's coming through, which is 10, which is correct for the wooden arrow. Works for both of them, and the arrow is getting Q-freed. Perfect. So the next part is actually just dealing with the floating text, right? For that, it's going to be really simple. We're going to create a component of node 2D. So this is going to just be called the floating text component. And I'm going to hit Control S. I'm going to save this under the components path. Now I'm going to add a script to this. Give it a good old-fashioned class name. Floating text component. And we're going to need access to the ready function, but we won't need access to the physics process or physics function. We're going to need two things. We're going to need a signal for emit underscore spawn underscore text. So we know when to emit the text without, or when to actually spawn the text without connecting it too severely to anything. And we're going to need an exported var for a text underscore label of type packed scene, which I'm going to set to null for now. Now we'll get through that in 1 second. First thing we want to do is create a new function. We're going to go func underscore set underscore text. There we go. So set text, it's going to need a new underscore text of type string. It's going to be of void return type. And all we need to do in here is set the text inside of the label to value. But for that, of course, we need a variable, which I have already forgotten about, called var current underscore text of type string. Set that equal to an empty string. And now we can just current text is equal to the new text. So we have our setter function. Now we're going to need a spawning function. Let's go func spawn underscore text of void return type. And for now I'm going to write pass. So the emit spawn text function, I'm actually going to want to connect this inside the ready function here. So I'm going to go emit spawn text dot connect. And we're going to need to connect it to a callable function. In this case, I want to connect it to the spawn text function. So what that's going to do is anytime this gets emitted, it's going to just run this function, which is really, really useful and really nice because it means we only have to connect this once and not really have to think about it again. So the next thing I want to do is go var new underscore text underscore label is equal to the text label dot instantiate, and then I'm going to write as a label. This will give us our autocomplete and spawn a new text label in. Now I'm going to just use add child and add the new text label. Then I'm going to write new underscore text underscore label dot text, and I want to set that text equal to the current text, so we're now getting the damage set on the label correctly. And then I just want to set the position, specifically the global position of the text label, or the new one we've created, equal to the global position of the floating text component. So that, if I hit Ctrl S and save, is our floating text component sorted. But there is this question here. What are we going to actually put inside this text label's packed scene? Well, this is where a really fun thing begins. We're going to create a new scene. It's going to be of other node, and it will just be a label. We're going to make a custom label. We're going to call this the floating text label. I'm going to hit Ctrl S and save. Because this is a UI element, I'm going to go and save it under a UI folder. I'm going to add a script to it. I'm going to give it a class name of floating, that's a 9, text label. I'm going to go and create a new variable, and this one's going to be for the velocity of the label, because we're going to want to actually have the label move, right? And for that, we're going to need a velocity of some sort. So let's go text underscore velocity, and it's going to be a vector2, and we're going to set that equal to a vector2 dot 0, so a zeroed out vector2, completely 0. Now we're going to need access to the ready function in a second, so let's go create that and write pass. And we're going to need access to the process function. Let's do that and write pass. So the last part of this is actually doing what's known as tweening. Tweening is a form of animation that we can use to programmatically animate something doing a thing. In this case, we want to programmatically animate our text shrinking and moving in a random direction, like a little bounce after a projectile hits it. So we're going to create a new function called func_tween underscore text. And it's going to be of void return type. And we're going to create a new tween. So to do that, we're going to write var tween. We'll set that equal to create tween. So this is just a really simple way of creating a tween. Next thing to do is we're going to need some variables to actually add in our x and y for our velocity, and it's going to be a bit random, so we get a programmatically random thing. We're going to go call that the var text underscore movement underscore horizontal, which is going to be an integer. I'm going to set that equal to a rand I. Then we're going to use the modulo or percent, and these are numbers that I come up with. I suggest experimenting with this a lot yourself to get any values you want, but what this basically is this is going to be the left and right movement of the horizontal movement of the text when it appears. So it's going to move left or right dependent on these numbers. I'll show you off how that works in a second. So the next thing we're going to want, of course, is a text movement vertical. So we're going to want vertical movement in our text. Set that equal as an int equal to, once again, the same thing, rand I %, and now we're going to need to flip what we're doing. So we're going to need to go, I'm going to use 20 plus 40 for this. And finally, we need to set that text velocity correctly. To do that, we just need to go text underscore velocity is equal to a vector2 and just pass through the horizontal. So text movement horizontal and text movement vertical. That's it, that's the actual movement of our text handled. Now, for this whole tweening thing that we created a second ago, this is actually going to be a it's a long line, but it's kind of simple when you get used to how tweens work. First, we need to call the tween. Then we need to use a specific function the tween has, because a tween is a class type and is a class name of a type of thing. So in this case, it's the type of tween. I go and click on that and click on tween. Lightweight object used for general purpose animation via script. We want to use the tween property function here to change the scale of our text. So let's go do that. Tween property. We're going to want to tween self, so just ourselves, so just the text itself. We're going to use the scale as the thing we want to tween. And we're going to want to move it down to a vector2.0. So basically we want our final value to be vector2.0. And then we finally need the duration of the tween, so how long it's going to take for it to go from its current scale down to 0. So let's go and here. I'm going to just do 1 second for now. And then I'm going to set the translation and the easing. So let's go dot set underscore trans. I'm going to go and click on this so you can see what that means. Set trans, this is the transition type. Sets the type of use transition from the transition type. If not set, it will basically just do whatever it is default set to. So what does that mean? Well, this is kind of an interpolation method that we could use to do something smoother. So if I go and call the tween class here inside the brackets, and then use dot transcubic, this is cubic transformation. It is a lot smoother. Yeah, I'm pretty sure it's a lot smoother than what it's kind of set to normally. So that's the cubic done, and now we want to set the underscore ease. Ease is basically the easing function of ease out, ease in. Is it going to go slowly in, slowly out, gently? It's very nice to just kind of have. So we're going to want to ease out. So set ease to ease out. And that is the tween sorted. Now there's going to be a problem that we will run into if we just throw this into our game. So let's go to the 2D scene and actually have a look at this. If I go and add text to this label, I'm going to just set this to, we'll set it to 999 because that's what it's going to look like. And I hit Control S and save. This is going to be, if I scroll all the way in, you can see that it's starting to get really, really fuzzy. And that's actually how it's going to look in our game, really fuzzy. We don't want that. Now, the reason why that's fuzzy is because, one, we are zooming the camera in, and two, the actual font sizing isn't correct for the font itself. Now, if you're using a pixel-specific font, you can just set it to the correct font size, and it should work fine. Because I'm not going to be doing that, I found a workaround. And it's actually really simple. What I'm going to do here is I'm going to go to Theme Overrides, Font Sizes, and I'm going to set this to a relatively large font of, say, like 86. As you see, it's a little bit cleaner. Then I'm going to go up to the constants, and I'm going to add an outline, and I'm going to just give it a little bit of, I will say 12 pixel size. So that is, zoomed out, a little bit easier to look at. The next thing to make this even easier to look at, however, is if we go down into the fonts itself, I'm going to add a system font to this. It doesn't really matter what system font you want to add, use whichever one you feel suits you. If you want to use a system font, if you don't want to use a system font, find an actual font that you can use online. There's plenty of resources out there for them. I'm going to use the impact font here, just because it looks a little bit more blocky and kind of easier to understand for at least what I'm going for. So now here's the question is, we've made this font really huge, it's going to be even huger in our game. That is true. So what I'm going to do is I'm going to go down to the transform, the scale. I'm going to set this down to 0.08. Maybe 0.08 is a little bit small, but let's hit Control S and save, and we'll figure it out in the game. So what do we need to do now? We need to go to our floating text component, and we need to add a text label to it. So let's go and do that. We want the floating text label, and we're going to add that, and hit Control S and save. And now we need to link it together a little bit, and to do that we're going to do it inside the target dummy script that we set up. So we know that we're getting the damage through via print, which means we should be able to just add the component that we want to add, so in this case the floating text component, And then we should be able to grab a unique reference to this. That is not what I wanted to do. There we go. Add a unique reference to it and just call the floating text component dot set text. We're going to want to pass through string variable for the damage, like so. And then we can just go floating text dot component dot emit spawn text dot emit. And then I can share Control S and save, and that should actually be it. Let's go hit play and figure out how this looks and if it just crashes. Why is it not working? Well, that's because I forgot to add the physics process, the actual process and ready function calls. Let's go do that. So under ready, we're going to want to call tween text. And under process here, we're going to want to go to the position and set that minus equal the position dot lerp. So we're going to linear interpolate between the position minus the text velocity minus 50. And then we're going to want to times that by delta. Now if I hit Control S and save, this will give a very, very smooth transition when we actually shoot our arrow into a thing. So let's go actually have a look at that. Click. And there you go. There's our little random damage numbers. You can see they are randomly spawning in a location above the target itself. They're going at slightly different speeds, and yet they're relatively visible, and they look pretty sharp as well. But that's pretty much it. That's floating text numbers. Now, if you want to modify this, I suggest messing around a little bit with the vertical and horizontal text movement and this -50 inside here. So this -50 is basically the weight, or how fast we're going to linear interpolate between the current position and the position minus the text velocity. And that's pretty much it. That's the whole text thing done. Little short video for today. I hope you're having a great day and a great game dev journey, and if you need any assistance, either come down to the Discord, a link is in the description, or shoot a comment. Yeah, have a good day.